Okay, so my name is Cameron Stewart, and today I will be presenting on acid rain for my environmental economics class. So basically, acid rain is described as any form of precipitation with acidic components such as sulfuric or nitric oxides. And these two pollutants are direct causes of acid rain being emitted into the atmosphere. A small part of a small part of both these oxides come from natural resources, but a majority stems from the burning of fossil fuels. Two-thirds of sulfuric oxide, and then one-fourth of nitric oxides in the atmosphere come from electric power generators. So basically the burning of fossil fuel. So some negative effects. Lakes, streams, wetlands, and other aquatic environments become acidic from acid rain. Aluminum essentially gets into water, and this aluminum is absorbed in the soil, which is carried by these water bodies. And this aluminum can be dangerous to crayfish, clams, fish, and other aquatic animals. And it also creates an atmosphere where you have this sort of trickle up problem, where say when a bird or a larger fish or organism or predator will eat a fish or crayfish or clam that has been infected by this acid rain, that acidity goes through each and every organism, and that can affect humans in a negative way solely based on consumption of those organisms. Also, acid robs soils of essential nutrients such as calcium. And these nutrients make it harder for these trees to take up water as it impedes the roots from collecting water. And it just makes it harder for trees to grow. As you can see in the title slide, I have a picture of an environment where acid rain is, essentially destroyed in a destroyed environment. The trees have barely been able to soak up any water. The water, as you can see, is pretty disgusting, and it's just been deformed by all the acid and pollutants on top of the water. The trees have no leaves and have no stems, and they're basically just straight dead wood. So some economic impacts. Essentially, acid rain can affect a handful of sectors, specifically fishing and lumber. As you know, with fish, if fish are dead, you can't really fish for them. And with lumber, as you saw in the first slide, trees can be deformed or degraded, and that makes it hard for lumbermen to actually find good and solid trees where they can improve their stock. The impacts are more aligned with regulation of air pollutants by governments worldwide actually than true effects of acid rain. For example, in the United States, the cost to reach phase one of the regulation standards in the Clean Air Act, which was signed in 1970, were about $500 million per year to reach phase one, and then an average of $3.3 billion per year for phase two. But at the same time, acid rain can have an exponential effect on these industries. So ideas for government regulation. Essentially, an idea that I found cool is a cap and trade policy, and it is cost effective actually. To sum it up, it's a cap on greenhouse emissions, basically like a carbon tax or a carbon cap. But in this sense, it's going to encompass a whole host of greenhouse emissions, specifically sulfuric oxide and nitrous oxides. And the trade part is buying and selling allowances that let companies emit a certain amount. As you can see at the bottom, these are described as transferable permits. And on top of that, you can also have subsidies for companies, subsidies for businesses and organizations that turn towards more clean forms of energy, such as wind, solar, or hydroelectricity. But on top of this, you can use it in a market-based economy and not just a controlled economy, because supply and demand can set the price of those transferable permits. Another Another piece of government regulation that I alluded to was the 1970 Clean Air Act. And as a result of this Air Act, it's cut sulfur emissions by 88% in the United States from the years of 1970 to 2018. It's been very effective because it's regulated greenhouse emissions and then just provided a whole host of subsidies and extra money for companies that abide by their rules. And basically, that is my presentation on acid rain. Thank you.